All right, we got the homework 13.2, the first two, which kids will just leave blank for no good reason. To convert from degrees to a radian, you need to multiply by pi over 180 degrees because you're making it a pi rad. And vice versa, radians to degrees, you want the radian to disappear, so you divide by a pi radian. Drawing the given angles shouldn't be hard. All angles start by being drawn on the positive x-axis. They then rotate to the terminal side. So I'd cover 90, 180, 270, and just a little bit more. Now what this would leave a 60-degree reference angle, which is a nut message for another day. It leaves a 60-degree reference angle. If you're looking at something like number 6, you're probably going to want to convert that to degrees. Now I know that pi is worth 180 degrees, so I'm just going to plug in a 4 there. I also know that 180 divided by 4 is 45, so this is negative 5 times 45, which is negative 225 degrees of rotation. Now, a negative angle rotates clockwise, so we're going to start here. We're going to rotate 90, 180, and another 45 degrees. That's what a negative 5 pi over 4 angle looks like. Let's see here. Why not? 7 looks scary to kids, doesn't it? 26 pi over 9. That's 26 180s sitting over a 9. That's 26 20s because 180 divided by 9 is 20. And 26 times 20, I feel like that's 520 degrees. Now, what is that going to do? Well, that's going to rotate positively, which is actually counterclockwise. It's going to rotate 360 degrees. All right, so I'm going to take away that 360, and I'm going to have 160 degrees of rotation left. So another 90 and another 70. And that's what that angle looks like. 9 is kind of a silly graph. If you do this in degrees, that's 680s, which is 1,080 degrees. And that ends up being 3 full circles. That's what that is. It's 3 360s, kids. You rotate once, twice, thrice. So what it does, it starts here and it stops there. Moving forward, convert the degree measured to radians or the radian measured to degrees. Show your work. Always show your work. All right, so to go from a degree to a radian, we multiply by pi over 180. Now the zeros cancel, and 4 over 18 is 2/9, 2 pi over 9. Now I know that some of you guys are numerically challenged, and yet for some reason you have decided you want to take dual enrollment math next year, and it will be a complete disaster. I don't know who thought that would be okay for you to do. I don't understand this. So the number was 40. We're going to not put the pi in there. Times 1 over 180, and then I'm going to magically hit the math enter key, and by God, it's going to give me 2/9. And don't forget about z pi. 13, you can do one of 2 ways. I'm a big fan of knowing that pi is worth 180. And then I can do some reduction here if I want. 180 over 12 is 15, so it's 5 15s, which is 75. What else could we do here? We could take 5 pi over 12, and we could multiply it by 180 over pi, and of course the pi's cancel, and you end up with that line right there, right? Let's see here, 15, 1.7 radians. So to convert a radian into a degree, we multiply by 180 over pi, and this is an ugly number. You're gonna legit have to use a TI-84 to do it, because the pi's don't cancel, and that was 1.7 times 180 over a pi. And it's about 97.40 degrees. For this one, C notes. Don't be the kid who actually writes down C notes. C notes, okay? And that's all I feel like doing in that little mixture. Find 2 angles coterminal with the given angle. If the angle is in degrees, leave your answer in degrees. If the angle is in radians, your answer needs to be a radian as well. So a 312-degree angle would look something like this. All right, now there's two other angles that are coterminal with it. One of them is where you just go all the way around the circle again. That means you add 360. Actually, there's an infinite number of things that are coterminal, but 312 plus 360 is what, 672 degrees? The other way of doing this is thinking about the negative rotation that takes you to the same location. And that would be found by doing 312 minus 360, which would be negative 48 degrees. Easy peasy. Now, when you start talking about radians, all you do is you add or subtract twice pi. So, a lot of y'all don't want to seem to learn fractions. And again, you think you're worthy of doing Roman math, and you're not. You're bridge math. We're going to have the same common denominator. So we're going to change that 2 pi into 12 pi over 6. And 15 pi plus 12 pi is 27 pi, sitting pretty over 6. You could also take away 2 pi. So that'd be 15 pi over 6 minus 12 pi over 6, which is 3 pi over 6, which is 1/2 of pi because of simplification. And 23, you're supposed to just add or subtract 2 pi, and you can't make this number a pretty number. It's just not doable. And the reason I'm adding or subtracting 2 pi is because it is a radian. You get about 9.71 if you add. We'll put RAD for radian. And if we subtract, we get about negative 2.85. Let's see, and then we have 24, and that ends it for part 1. Latitude and longitude are measured in what is called DMS form, degrees, minutes, and seconds. If there are 60 minutes in a degree, 60 seconds in a minute, the notation 50 degrees, 30 minutes, 10 seconds represents an angle with a measure of 50 degrees, 30 minutes, and 10 seconds. All right, write the angular measure 70.55 degrees using notation above. Well, first off, this is 70 whole degrees plus. Now, we have to take this decimal and we have to convert it into minutes and seconds. So I know that there are 60 minutes in a degree. So I'm going to, anyways, I lost my place here. I'm going the other way around here. It happened. BRB. Maybe not. Where was I? I have 70 whole degrees, and I have to convert this decimal into DMS. So I'm going to take my 0.55, and I'm going to multiply it by 60 because there's 60 minutes in a degree. And I'm going to get 33 whole minutes. I don't know why I wrote the plus. But notice how 0.55 times 60 was 33. So 70 whole degrees, 33 minutes. All right, write the angle measure 110 degrees, 45 minutes, 30 seconds, and there's thousandth of a degree. Well, they want us to convert to decimal. This is 110 plus there are 60 minutes in a degree. Now, how many seconds are there in an hour? Well, that'd be 60 minutes times 60 seconds, 3,600. It works the same for latitude and longitude. And then we're going to push some buttons. And there we go. It's 110.76 degrees. And there is a good chunk of your homework. You're welcome. Enjoy it. Use it. Study it. You have a test on the 14th. Good day.